Okay, so this is the third video, question 14. Which expression is equivalent to x plus 3 to the third power minus 9x times x plus 3? So this is just a subtracting polynomials. First thing that you want to do is multiply out both of your expressions here. So x plus 3 cubed means x plus 3 times x plus 3 times x plus 3. So 3 binomials basically. I can multiply 2 of the binomials with box method. So x plus 3 times x plus 3. I get x squared, 3x, 3x, and 9. So these two multiplied together became x squared plus 6x plus 9. That still has to get multiplied by that third x plus 3. We can do another box method, a 2 by 3 box method, to get that expression. So x squared plus 6x plus 9 on top, x plus 3 along the side. X times x squared, x to the third. 3 times x squared, 3x squared. 6x times x, 6x squared. 6x times 3, 18x. 9 times x, 9x. 9 times 3, 27. So that becomes x to the third, adding on my diagonals, plus 9x squared, adding on my diagonals, plus 27x plus 27. So that's this first expression all multiplied out. Second expression, negative 9x times x plus 3. Negative 9 is going to be distributed to both parts. Don't forget about your negative sign. Don't drop it. So negative 9x times x means minus 9x squared. Negative 9x times 3 means minus 27x. So that's going to get tacked on at the end of this really long polynomial I just made. Negative 9x squared minus 27x. Combining like terms to simplify. So x to the third, I only have x to the third. So that's going to come down. Positive 9x squared minus 9x squared means 9x squared eliminates. Positive 27x minus 27x means the 27x eliminates. And plus 27 is all that's left. So x to the third plus 27a becomes your final answer. Okay, 15, suppose p of x equals x to the third minus 2x to the second plus 13x plus k. The remainder of the division of p of x by x plus 1 is negative 8. What is the remainder of the division of p of x by x minus 1? So remember, this is a factor, x plus 1. That means the 0 is the opposite. The 0 is negative 1. The remainder theorem says if I plug negative 1 in for all of the x values, out will pop that negative 8. That means I'm going to put negative 1 in for all these x values, leaving k as the variable I'm trying to figure out, and out will pop a negative 8. So I'm going to set up the equation. Negative 8 equals, so that's for p of x, so that's my remainder that's going to come out. And I'm going to plug negative 1 in everywhere I see x. And that equals negative 1 to the third minus 2 times negative 1 squared plus 13 times negative 1 plus k. And I'm going to solve this for k. So negative 8 equals negative 1 to the third is still negative 1. Negative 1 squared is positive 1 times a negative 2, still keeps it minus 2. Positive 13 times negative 1, now we'll make it negative 13, and I have a plus k. Combining like terms. So negative 8 equals, get my calculator so I don't make a mistake, negative 1 minus 2 minus 13, negative 16 plus k. Now add 16, add 16. Negative 8 plus 16 is a positive 8, so k is equal to a positive 8. Now that I know k is a positive 8, I can replace that with an 8. And now what is the remainder of the division by p of x by x minus 1? So remember, that's the factor. That means the 0 is its opposite. 0 equals 1. So remainder theorem says if I plug 1 in for all of this, out will pop its remainder. So I'm going to go ahead and do that. I'm going to plug 1 in. So p of x, because that's what we're figuring out, equals 1 to the third minus 2 times 1 squared plus 13 times 1 plus 8. 1 to the third is 1. Negative 2 times 1 to the second is just minus 2 plus 13 plus 8. And I'm just going to plug that into my calculator. and I get a 20. So 20D is my remainder when I factor p of x by x minus 1. Okay. 16, what is the approximate solution to the equation 3 raised to the x minus 1 equals 4 raised to the 2x plus 5? So remember, you should remember that if we have a variable in our exponent, that means we're probably doing a log. Okay? I'm getting another piece of paper just because I'm running out of room. So I'm going to set this up because I need to figure out x. So I'm going to do log of both sides. 3 raised to the x minus 1 equals log of 4 raised to the 2x plus 5. When I do that, I am able to move the exponent to the front of the log. So I get x minus 1 times log of 3 equals 2x plus 5 times log of 4. So I'm just solving for x now. So I'm going to divide both sides. I could divide either by log of 3 or I could divide by log of 4. It should not change your answer for x. I'm just going to divide by log of 4. When I divide my right side by log of 4, it will go away. When I divide my left side by log of 4, I'm going to do log of 3 divided by log of 4. Make sure you close the parentheses. And I get about 0.79248, etc. That log of 3 is being multiplied to this x plus 1, so that 0.78, I'll just say 25, also needs to get multiplied to the x minus 1. Equals 2x plus 5 because that log of 4 is gone. This is just multiplication. Even though it's a big scary number, it's still distribution property. So distribute 0.7825x minus 0.7825 equals 2x plus 5. Solving for x. So I'm going to minus 0.7825x from the left, minus 0.7825x from 2. I get negative 0.7825 equals. So I'm just going to do 2 minus 0.7825, 1.2175. X. Okay, getting there. So minus my 5. So now I have a negative 0.7825 minus 5, and I get negative 5.7825. Equals 1.2175x. Again, don't let big decimal numbers scare you. I'm still just multiplying that to x, so I need to divide it off. Dividing by 1.2175, 1.2175. So, negative 5.7825, I don't even know if I said that right, divided by 1.2175. And you get negative 4.7494, so for x. So negative 4.749 equals x. So looking at our answer choices, obviously we might be slightly off just because of, where we stopped the decimal. The one that's closest to my answer is D, negative 4.797. Okay, 17, in the figure below, PR and SR are tangent to circle O. Keep in mind that tangent means they are intersecting exactly at one point. Tangent also on the circle. Tangent also means it makes a 90-degree angle with the radius. Okay, so all of these little pieces are helpful when we go to solve our problem. And you should know that these are equal because they're both a radius. Okay, if O to T is 11 centimeters, so mark or draw a picture on your paper since you can't mark on the computer when you take your EOC. That's 11 centimeters. P to R is 60 centimeters. What is the length of OR? Wait. Oh, sorry. I did this incorrectly. Sorry, guys. O to T, I didn't realize. O to T is 11 centimeters. I just marked the whole thing. And they want to know O to R, this whole length. Okay, you know that whole length. So this is just Pythagorean theorem. If O to T is 11 centimeters, that is a radius. That means O to P is also 11 centimeters because that's also a radius, and all radius are equal. So this is going to be your Pythagorean theorem. A squared plus B squared equals C squared. A is 11 centimeters, so 11 squared. We don't know B, the whole length O to R. We don't know, but that's one of that is the hypotenuse. Okay, we know part of it's 11, but we don't know the whole thing. That's your hypotenuse. B is your other leg here of 60 centimeters. So I'm going to say 11 squared plus 60 squared equals x squared. And you can just plug that into the calculator. 11 squared plus 60 squared. You get 3,721. So 3,721 equals x squared. How do we undo a squaring? We square root. So square root, second x squared button, 3721, and you get 61. 61 centimeters equals x. So your answer here is A, 61 centimeters. Okay, in the figure below, the larger circle has a radius of 6 centimeters and the smaller circle has a radius of 2 centimeters. What is the approximate area of the shaded region? So we are doing a sector area. Keep in mind sector area equals the arc or angle measure, the measure of the arc, divided by 360 degrees times pi r squared. That's your formula. And you're going to have to be doing some subtraction here. Okay, so if you notice the large from the center out, the large radius is 6 centimeters. They drew it over here for you, but I'm going to also draw it there where my actual sector is. And they also told you that the smaller radius is 2 centimeters. For both of these, we have a 30-degree angle. So if you take the large sector area, that would be if this whole pie piece was shaded, and I subtract that really small sector area that's not shaded, then you're going to end up with the piece that is shaded that you want. Okay, so that means we are doing large sector area. The measure of the arc is 30 degrees for both. So 30 divided by 360 times pi 6, because that's the larger radius, squared. And I am subtracting 30 divided by 360 pi 2 squared, because that's the small. Okay, and if you do all of that, you will end up with your shaded area. So I'm just going to plug this whole thing, the whole first part, into my calculator. Parentheses 30 divided by 360, make sure you put parentheses around it, times pi 6 squared. Pi comes from second, upper arrow key. And I'm just going to hit enter. And I get 9.425, we'll say, minus, I'm going to do the exact same thing with the other one, 30 divided by 360 in parentheses, times pi 2 squared. And I get 1.047. So I'm just going to subtract those two numbers. And I end up with 8.378. So about 8.4. D is our answer for the shaded region. Okay, a system of equations is given. Y equals absolute value of x minus 3 and y equals 1/2 x. What is the distance between the points of intersection of the system? Okay, so I think the easiest way to do this is with Desmos. There is a mathematical way using distance formula and all that stuff. I think it's so much easier if you use Desmos. So if you plug both of these into Desmos, so my red, my V is, and you can see, it's so hard, I'm sorry guys with the projector. You can see my red is y equals the absolute value of x minus 3, and the blue is y equals 1/2 x. So anyway, you end up with this picture, and it's asking what is the distance between the 2 points of intersection. So it's asking what's this length here between the two intersection points of 2, 1 and 6, 3. What's that distance? So you can't count this. If you also look at all your answers, it's all the square roots. Okay? But what you can do is you can I'm trying to get the glare off of there. You can turn this into a right triangle, and then you can use Pythagorean theorem. I hope you can see that. I'm kind of trying to draw it over with my pinky. You can turn this into a right triangle, and then you can use Pythagorean theorem. Okay, I'm trying my best to show this to you guys, but I'm trying to put paper here so you can see kind of this right triangle that I'm making. And of course, it doesn't want to stick on the iPad right there. But anyway, and I'm kind of going to line it up, or try my best to line it up. So when you make this into a right triangle, it becomes Pythagorean theorem, and it becomes much easier to solve. So we just need to get our side lengths. Okay, so I hope that you can visualize that that is a right triangle right there. And I just need to figure out these side lengths. So this is counting by twos, just be mindful of that. That means two of these boxes is 1, so this side is 1, 2. So this leg is 2, and this leg is 1, 2, 3, 4. This leg is 4. So it's 2 and 4, and then we just solve it for hypotenuse C. Okay, so 2 squared plus 4 squared equals C squared. 2 times 2 is 4, 4 times 4 is 16, so I get 20 equals C squared. I'm going to square root the 20 to get C. C equals the square root of 20. Well, square root of 20, I'm so sorry, I am all crooked. Square root of 20 is not any of my answers, but you have a calculator for all of these. I can show you how to convert this out, or plug the square root of 20 into your calculator. You get this crazy decimal, and plug all of your answers into the calculator and see which one also equals this crazy decimal. Okay? But underneath the square root of 20, we have the square root of 4 times 5. 4 times 5 is just 20. 4 is a perfect square. If I square root 4, I get 2, and I leave the square root of 5 underneath because it's not a perfect square. And that, my friends, is why your answer is B. Okay? So algebraically, you should solve that using distance formula and crazy stuff. But if you have access to Desmos for all these questions, plug it into Desmos, and the distance between these 2 points can be made into a right triangle. And then you can solve doing Pythagorean theorem. Okay? All right, last question on this page, and then this video will be done. Fred drives an average of 15,000 miles per year, and his car gets 20 miles per gallon of gasoline. The average cost of gasoline is $3.25 per gallon. He buys a new car. In his new car, Fred continues to average 15,000 miles per year, and the average cost of gasoline remains the same. Approximately how many more miles per gallon does the new car get if Fred has a savings of $650 per year on gasoline? So there's a lot going on here. So first thing I want to do is figure out basically the cost that he's paying for his car and for the gasoline. So I'm going to take his 15,000 miles divided by his 20 miles per gallon, and I'm going to multiply that by my $3.25 per gallon. Okay, miles divided by miles per gallon of gasoline times how much he has to pay per gallon of gasoline is going to get you his total cost he's spending on gasoline. So that gets me $2,437.50. Okay, I'm going to subtract his savings of $650 per year, and I get $1,787.50. So now we want to know his new, how many more miles per gallon does he get with his savings. So we're going to take, so that's our first step. Second step, we're going to take our 15,000 miles divided by X, because this time we don't know his per gallon, miles per gallon. Still multiplying it by 325 and equaling it now to the new dollars, $17.87.50. Solving it for X. So I'm going to multiply these two things across the top. Get 487.50 divided by X equals 1787.50. I can put that over 1, and now I can have a proportion. So I'm cross multiply 178750x equals 48,750, divide off 17,870 to get X. Get my paper. So X equals, when I do that, X equals 27.3, and I subtract off his 20 because it wants to know how much more, and we get 7.3 miles per gallon more with his new car, with his $6.50 savings. Okay, end of this video, we've got probably 2 more videos, 2 more pages, and then you'll be done this first exam review. So take a stretch break, try to solve some problems on the next page, and then go to the next video to watch.